Okay, I'm pretty sure everybody who owns a 3D printer knows this situation.
Whoa, this print needs 42.45 grams of filament.
Oh. I hope that's enough filament.
Wow, that print needs 909.07 grams of filament.
Yeah, that should be fine. I've been working with 3D printers for over 6 years now, and I'm tired of worrying about running out of filament. So I decided, let's make a device that shows me how much filament is left. Now there are different methods to measure how much filament is left. I could use a scale and just measure the mass, or I could measure how much filament was used in the parts that are already printed now and then calculate the remaining mass, but that is too complicated and I want to make it simple, so I came up with another solution.
Okay, my idea here is really simple. This black part here is the filament spool. So the filament is stored between those two black circles, and that's resembled by this green line. And my idea is that I have a pivot point, a fixed pivot point, and then I attach an arm to this point. So when the filament spool is full, I can measure the angle, which is better right here, and then I hold it to the lower circle, so to the inner diameter, and measure the angle again, and this is alpha. And then I can calculate the angle between those two arms, positions. And with that I am able to figure out how much filament is left. But to figure out the angle, I have to measure it, and therefore I want to use a potentiometer right here at the pivot point. And since I'm using an Arduino, I just have to save the readings on the potentiometer. So when the arm is at this position right here, so it's the better angle, the potentiometer gives me out a value about, I don't know, let's say 850. And when the arm is at a lower angle, so alpha, the potentiometer gives me a value of 485. And these two values I can calculate the difference and make the same calculations as I would do it with the angle between those two positions right here. Yeah, so let's make it.
So this is my setup right here, and I already programmed a little sketch. So let's have a look at it. I hope you can see it. So first we have the mass, and I can increase it by turning this knob. Then I hit that button to save it. And here we have the first set point, so this is the lower angle. I hit that button to save it, and here we have the bigger angle, so I increase it and I hit that button. And now you can see this is the remaining mass. I can turn it and you can see that it indicates how much filament is left. So now I just have to solder everything together. For the mechanism that measures the angle, I want to use a putty, as you already saw. So now I just have to model the other parts and print them out. And here I have all the parts 3D printed. And I have this wooden rod right here that I have to cut to length so that I can stick it into the parts and it acts as a spacer. And here we have this little arm. So there is this little paddle-like end on it, so that it fits perfectly into these filament spools. And when the filament spool is empty, it's down there. When it's full, it's up here. So I show you that like this. So look that it's seen through here. So you have to imagine you're looking from the front when it's standing. Filament is empty and filament is full. So now I can measure how much filament is left, but I still need a way to store the spools. So I need a filament box. I already made a filament box, which is this one right here. I designed these little arms to guide the filament up to the printer there, but there is room to improve. For example, the spools run on this little stands and they are permanently in this box. So not every filament spool fits in there because I can't move the stands. So let's fix that.
Okay, so to fit every spool, I came up with a system right here that consists of 2 wooden rods, 4 wooden rod holders, and at least 2 spool holders. But you can add more spool holders if you want to. And these spool holders are designed in a special way. For example, let's have a look at them from the side. So this is the half spool holder it's cut through. And as you can see, there is the hole for the wooden rod, and then here is another pocket and a hole going straight through, so that I can put a nut right here and then a bolt through there. And when I bolt this in, the bolt comes out at this end and presses against the wooden rod. And this is because I can now adjust the width of the spool holders. For example, I slide this over here, then I screw the screws in so it presses onto the wooden rod and is fixed there, and then I adjust the width to the spool, for example here, and screw that in so that is fixed as well, and I have the perfect spool holder. Now I say I have another material or another brand and they have another spool size, so I just go ahead and slide this over here or over there and bolt it again, and so it fixed to the right spot. So that's my design. Now let's print it.
So here I got all the parts 3D printed. I also made a little cover and a little sign for the display, and here are the spool holders. So let's put everything together. Okay, so now I set the mass. I set the mass to 1000 and I hit this button to save it. Now for the bigger angle, I let it sit on there, press this button to save it. For the lower angle, I just hold it here and hit this button to save it. And now every time I hit this button to turn on the printer, this thing turns on as well and tells me that I have 980, 1000, a little bit of noise in there, grams of filament left. And it's done. Now I can see how much filament is left and store a lot of spools in the filament box. But there is still a big problem. Some of you may have noticed that to use a system I would have to measure the biggest and the smallest angle every time. And that makes it basically useless. But what if I tell you that I found a really simple way to work around that?
I am talking about the EEPROM, which stands for Electrically Erasable Programmable Read-Only Memory. There's also an EEPROM, that's a chip with a little window, and if you put it under UV light, the data on this chip gets erased. Maybe you've seen one of those in a museum. But no matter if it's an EEPROM or an EEPROM, they work the same when it comes to saving data. They have 2 transistors forming 1 bit and 8 bits forming 1 byte. So for 1024 bytes you only need 60,000 transistors. Now you can buy this EEPROM as an external unit, as you can see here, or you just use the built-in EEPROM. For example, the ATmega 328P U used in the Arduino Uno have a built-in EEPROM, or the ATmega 2560 used in an Arduino Mega has one as well. But how does it work? It's actually pretty simple. You can imagine it as a row of folders which have an individual address starting at 0. And now if you want to read the data in the folder, you just have to select the address. The Arduino syntax for this is EEPROM.read, and then you type in the address. So 0, 1, 2, 3, and so on. To write data, you select the address and then you write the data. In the syntax, this is EEPROM.write address, comma, and the value. But now it's important to know that in every folder you can just store a data between 0 and 255. Now with all of that in mind, some of you may think, but why is that the solution to the memory problem? And it's really simple, because when you store data in the EEPROM, it stays in the EEPROM. No matter if you turn off the power or turn on again, the data will be saved in the EEPROM until I erase it electrically or in the EEPROM with UV light. So I just store the value of the biggest angle in the EEPROM and the lowest angle in the EEPROM and the mass in the EEPROM, and I don't have to measure it again because the EEPROM will remember this data until I electrically erase it.
Now it just needs a name, and since it's a leftover filament detector, I decided to call it LOFD box. And with that, it's done. I'm so happy that I never have to worry about running out of filament again, and I think this thing turned out really useful and cool. If you think so too, then feel free to like, share and subscribe. Here are my videos, here you can find my channel. Don't forget to check out my Thingiverse for the 3D models of this project. Have a nice day and see you soon.